It's math time with Mr. Mock. It's math time with Mr. Mock. It's math time. Math 8. Hey, it's your on-demand Wednesday lesson. We're on lesson 16 of this unit, which is pretty cool. So remember, we had talked a lot about transformation. So that's translations, rotations, reflections. And then we talked about rigid transformation. Rigid transformation is when you use any of those, all of those, a combination of those to move a shape to a new location. And then we connected rigid transformation to congruence. So if something moves using rigid transformation, that means when it gets to its next destination, it's the exact same in terms of lengths and angles and everything. It's not getting bigger or smaller or shifting anything. Like it's not going to look completely different, all right? So now we are talking about parallel lines cut by a transversal. Yesterday we connected that to some key vocabulary that I just wanted to review real quick, all right? So first part of this, key vocabulary, parallel lines, all right? Parallel lines, two lines that'll never intersect. They run along each other, they'll never connect. Basically, they have the same, what we call slope, all right? So two lines, two or more lines, could be more, that will never intersect. They have the same slope. Now, at any point during this part where we're writing down the key vocabulary, you can pause and then write it in what you need to write, all right? So don't think that you have to wait for me to tell you to pause. Go ahead and you can always pause the video and write things down. And then we can come up with an example of parallel lines. And I like to use like a straight edge like this one, where there's this cool thing where you can go parallel lines would be like this. And my cat just walked right through and bumped my camera in the middle of me recording. How fantastic is that? Oh, hang on, fixed it. So what's cool is you can do parallel lines this way. You can go straight line, and look, those are parallel lines, right? On the same straight edge. Boom. So these would be parallel lines like that. Okay. And then the symbol for marking parallel lines looks like this. Okay. So those are parallel lines. Let's see if I can get back there. Hey, look at that. Woof. Bulldozer of a kitty cat. Next, a transversal. Say hi. Okay. Next, a transversal. A transversal is a line that goes through parallel lines. A line that goes through parallel lines. All right, so if I'm thinking about a transversal, and I'm going back to our example, a transversal would go right through these two lines. And I'll do this just in my black pen here. It would look like this. See how it goes through the two lines? That would be a transversal. Okay, and then it creates, look, 4 angles here and 4 angles here, so 8 angles total. Okay, now a straight angle. A straight angle is just a straight line. An angle that forms a straight line. An example would be a transversal, would be a straight angle, all right? Or it's an angle that measures 180 degrees. So it's an angle that measures 180 degrees, okay? So any line really forms a straight angle, okay? It's just a straight line. Now, alternate interior angles. And this was a big key vocabulary word that we talked about yesterday in our lesson. And if I move this down here, is that where it's going to stay? I don't know. Let's see. So alternate interior angles, they're formed when two parallel lines are cut by a transversal all right? They're formed when two parallel lines are cut by a transversal, and it's the angles between the parallel lines and on opposite sides of the transversal. Between the parallel lines, parallel lines and on opposite sides of the transversal. And opposite sides of the transversal. Okay, so when we look up here at our little diagram, when we're talking about alternate interior angles, that would be like this angle here, we can call it angle A, and this angle here we can call angle B. Those would be alternate interior angles. They're on the inside of the parallel lines and on opposite sides of the transversal. Okay, so why don't you go ahead and pause now. Maybe if you have to catch up on any of these definitions, please do that. Update your picture here, make sure that you label that. You can even come back here and go, look at diagram A and B would be alternate interior angles. You can leave yourself some notes there. Go ahead and pause, come back in just a moment, and we'll talk about angles in a triangle, which is our next section here, okay? Okay, and you're probably back, hence you're watching. So we're gonna go ahead and look at angles in a triangle, all right, which is this guy here. Okay, now, I'm realizing something I was gonna use for this lesson is not here. Hey, sorry about that. I'm back. Found what I was looking for. Now, when we're looking at this diagram here, okay, we have a triangle A, B, C, and then we have the angles in that triangle. And this is kind of a common geometry thing, is the angle is just the lowercase version of the vertex that it was labeled, all right? So this is vertex A, so it's gonna be angle A. Vertex B, it's angle lowercase b. Vertex C, angle lowercase c. And what I've done here, and I'm hoping maybe you can see it, is I've got these dotted lines, okay? And I want you to imagine that this dotted line and that dotted line, that they're parallel to each other, okay? And then I want you to think about some of the key vocabulary we've been using, right? If these are parallel lines, this would be a transversal, correct? And then can you see any alternate interior angles there? I mean, just kind of pause and think for a second. Would we have any alternate interior angles that we can label? Just think about it for a moment, and maybe go ahead and write in what you think where would be an alternate interior angle. Maybe to this one. Do we have alternate interior angles? And then I want you to come over here and look, this would be another transversal, right? So we have parallel lines cut by a transversal. Would this have an alternate interior angle someplace? There's something that I'm trying to get to here that's kind of interesting, all right? And we can also connect it to rigid transformation. Now, and it'll also show alternate interior angles. So what I was getting at is if I take this here, okay, and I look at doing a rotation, and I want to do a 180-degree rotation from the midpoint, It should be around right here. Okay. If I were to rotate this triangle 180 degrees, look at what happens to angle A. Well, first off, it matches up pretty awesome with the parallel line, right? Which is proving our alternate interior angle. But basically, look what happens. Where does angle A go? Angle A is just going to come right up there. Those are going to be equal to each other. Okay? So this angle here would also be angle A. This would be A degrees as well. And then if I do the same thing over here, using alternate interior angles or a rigid transformation, right? This would be a rigid transformation. I'm doing a rotation of 180 degrees right around there. Check it out. That angle C is going to be right here, which is pretty cool, right? So this would be C degrees. And the idea that we're trying to get across is if you have any triangle, you could draw any type of triangle, draw a parallel line across that opposite vertex like I did here, and you would have alternate interior angles every time. You could use a rigid transformation every time and move these two angles right up here. And what you discover is that the three angles of a triangle always add up to 180 degrees. Okay? And that's really the big key thing for today. The angles of a triangle add up to 180 degrees. These three angles, every triangle, no matter who draws it, we can all draw our own unique different triangle, and this will work, where the three angles will form a straight angle. 1, 2, 3, those form a straight angle, which is 180 degrees. That's pretty cool. So the main thing to write down, the angles of a triangle add up to 180 degrees, and you can even add always, always, and always. Any triangle, anytime, every place, every day. Now, your quick example that I want you to try, your quick practice, is this problem right here. All right, I've drawn a triangle. I'm telling you that this angle is 92 degrees. This angle is 52 degrees. So what does this angle have to be? So I want you to think about what we just talked about. And then what you're going to do is you're going to put this in, when you submit this to be done for your assignment today, just send me a comment with what you think X should be equal to. Even if you get it wrong, it's okay. I just want to see what your thought process is. And if you want to tell me how you got it, that would be great too. But that is your last thing for today. I hope you all have a wonderful day. I will see you all soon. Bye. Video over. Mock out.